in 1 minute. I hope that works for everyone. So welcome everyone to our second webinar as Rocket Science, and the first branded as the MLOps Institute, which is our new certification company that will be offering a MLOps Engineer Certification course, as well as a lot of content around MLOps, and just really trying to build a community. A lot of the people who joined last time were able to join our Slack channel, and some people currently follow us on our LinkedIn page. So we've been putting out daily content on the LinkedIn there about MLOps tools and what we think is best. If you're a data engineer, if you're a machine learning engineer, data scientist, etc. So all that's fun stuff. And today we're going to be breaking down SageMaker and Databricks. So a bit of an overview is going to be, we'll start with a intro from Mohammed about lifecycle management, and then we'll get into a demo of Databricks from Asim, who will be also offering a pros and cons and a demo of the actual product, and then SageMaker from Eric doing the same thing. And at the end, we'll do a wrap up with a comparison. And all the way at the end, if you guys have any questions, feel free to stick around to the end. We'll be hosting a bit of a Q&A to answer all your questions about the tools. So we're excited for that. Go ahead, sorry.
I'll take like a couple of minutes before the Q&A at the end to talk about the MLOps Engineer Certification. So people interested in MLOps engineering and looking for programs to master their skills, they can stay at the end. And we can talk about it and discuss the certification.
Excellent. Okay, so with that, let's get started. So welcome to Clash of Titans, SageMaker versus Databricks. This is what's on the agenda for today. So we'll do a short intro, lifecycle management, Databricks, SageMaker, and Q&A. And we'll try to, we'll definitely be on time. So we'll be going through some of the stuff fairly quickly. There will be a recording of this webinar that will be posted to our YouTube channel in the following days. So the current people presenting, so I'll let you guys introduce yourselves, starting with Mohammed.
So hello guys, my name is Mohammed Sabri. I'm the founder and CEO at Rocket Science Development. I've been spending almost the last decade in AI and data analytics consulting, helping companies basically solve complex problems with a strong specialty in machine learning operation, or MLOps. I have the chance today to work with a great team of 10 people. We're involved in developing innovative in-house solution in the field of machine learning operation, but as well helping the resource and the market with our expertise.
Eric?
Yes, so hello everybody, I'm Eric. I work as a machine learning engineer at Rocket Science. I have 4 years of experience as an MLOps engineer, even though MLOps engineer is a quite recent term. Actually, I fell in the soup while working on machine learning projects, mixing cloud and high performance computing together. So I got the opportunity to think about the whole machine learning stack a bit before everyone, in a way. So yeah, so I've been exposed to everything MLOps quite early, and it's a really interesting space, and I'm happy to present today.
Sim? You're muted. Yeah.
There you go.
Okay, perfect. So hello everyone. My name is Asim Sultan, and I'm working as a machine learning engineer at Rocket Science Development. I've been working in machine learning and in NLP projects for the last couple of years. And currently, as Stephen said about the MLOps certificate, so I'm working heavily on that. We are building a certificate from an end-to-end, from machine learning to the model production, a very useful certificate actually. So I'm just spending my whole time on that certificate. And today I'll be giving a demo session, and I'll talk about the Databricks platform that we use for the model development and putting our model into production. So yeah.
Great. So those will be your webinar presenters. A bit about the MLOps Institute. So it's something that we built really because we felt that there was no current place for people to go as as a thought leader for resources in MLOps specifically. There exists for machine learning and for data science, but really as a company, we've been focusing on building something that's specifically for MLOps. And so we have a lot of people represented in the community right now, as you can see. And our goal really is to create the future of MLOps and turn anyone who wants to be a leader in MLOps in the future by certifying them through an accreditation program and offering them tools and resources daily to be able to continue learning and becoming better at MLOps. As a company, we're Rocket Science. We do end-to-end machine learning strategy, development, and deployment. It's really the last stage of the machine learning lifecycle. If you're familiar with MLOps, then you'll know what we do. We currently have 4 offices worldwide: Canada, US, the UAE, and Qatar. So we've been growing really fast as a startup, which has been really exciting, and we're looking to continue growing and increase the team size to about 50 by the end of the year. So that's all good news. And current book of clients include L'Oreal, Take-Two, Ericsson, Questkey, Al Jazeera. So what we do now is a different use case for each client as a MLOps managed service. So depending on what they need, sometimes it's within the marketing subdivision, sometimes it's something more technical like anomaly detection within 5G. And so that's us as a company. And now I'll let Mohammed get started with the webinar.
Awesome. So thank you, Stephen. One of the most important aspects in data science is lifecycle management. What lifecycle management means is basically your ability to oversee the different steps in your data science process, from the experimentation development to the ability to deploy potential models or solution. Now, in term as well, it includes as well everything from the infrastructure part. So every environment and so is included in lifecycle management. The majority of companies and people tend to work in a way that is not necessarily efficient. It works, but it's not necessarily efficient. And when it's not efficient, it doesn't scale. So at the end, you end up with the environment and lifecycle that get to a result, but not necessarily the one that will help you scale the data science practice, because it's fine to be able to deploy 2-3 models and to have a team of 1-2 data scientists potentially. But when your team grows, the idea, the more it grows, it shouldn't have any impact on the quality of the outcome or any timeline issues or any production problem. You should be able to scale with no problem. And that comes from the lifecycle management. And what the people responsible for the lifecycle management are the MLOps engineers at the end of the day. And one of the important potential avenues that are usually explored by companies for lifecycle management are usually end-to-end machine learning platform, like what we will see today, SageMaker or Databricks. Of course, there are other solutions in the market in addition to SageMaker and Databricks, but we decided for this webinar to focus on both because technically they're among the top most popular one. We're not saying that they're the best, because I would say it's hard to answer that question, but I would more tend to say that they are, when you look at the statistics, they are just the most popular, among the most popular today in the market. An end-to-end, one very important thing, an end-to-end machine learning solution like SageMaker and Databricks doesn't do everything. Okay, it doesn't exist yet a platform that is literally covering everything in terms of needs that you have. But usually they help cover like a good part of it, a good piece of it, from 50 to 80% of your needs. And then your work is basically doing integration of this platform with your environment, your life cycle management, and add up any additional solution or tool to this technological stack that you would have to basically have an optimized life cycle management. In terms of data science, pure data science, usually the data scientists are not necessarily overseeing that aspect of lifecycle management, just because it's not necessarily under the scope of their work. but it's very important for them to stay involved with that because they represent and they are an important actor within that life cycle. So what I will do, I'll let Asim deep dive into Databricks. And after he's done with Databricks, we'll move on to SageMaker. And after we'll do a wrap up around both solutions. You're unmuted, right? Oh, there you go.
Okay, perfect. So hello everyone once again. So today we'll talk about Databricks, and as Mohammed said, that's basically an end-to-end machine learning platform. So we use it to actually build a model, train a model, do all the hyperparameter optimization, and then finally put our model into production. It's a unified analytics platform. So basically it allows data engineering teams and data scientists to work in one centralized place. So what you do is you run all of your analytics in one place, and it offers serverless computation and a unified governance, which is one of the key important factors when we are working with the big data, because we need to keep the track of the data and we need to see how our data is performing. So this is where Databricks comes into the picture, and from ETL to model training and to inference, everything comes under the the Databricks platform. So some of the features are access control. It allows us for a beautiful dashboard and visualization. So today, even in one of the demos that we'll be doing, so we'll see some of the visualization. We will run a notebook as a job, and it allows us for the interactive exploration, job scheduler. It has a secure deployment, and it allows us for collaboration and auditing. So I'll just start sharing my screen, and yep, we can. Okay, perfect. Okay, so today what we will do is we will actually train a machine learning model on a Databricks platform. But what we will do is we will also put that model into production. So what happens is that when we actually work on a machine learning model, we just leave it as a notebook, and we rather not, if we have to deploy it, so we use some other tools and stuff like that. But what Databricks allows us is that, and also about the the big data. So if we have a huge amount of data, so we have to write the Hadoop clusters and all that stuff. But Databricks allows us to just create cluster in one click, and then to start creating your model, and everything, the computation itself is taken care by Databricks clusters, which are running on the backend, which we will actually create one of them today, and then we will see how that model gets into production. So firstly, we will import the data, and this is one of the important things to discuss. So you can just click here on the file and then upload data. In here, you guys can just choose your CSV file or any file that you would like to work on or to create your model. What we are working on today is basically to detect the wine quality, and the data set is available here. So if you guys can, we'll be sharing this notebook, so you guys can go through this entire notebook from beginning to end, and then we will perform some visualization on this data. We will run a parallel hyperparameter tuning on that machine learning model. We'll be using a random forest model, and then we will also work with MLflow, one of the very substantial tools, I would say, these days, which actually manages the entire life cycle of the model from development to production. It logs everything, so you can see all the models that you have created, so how much each one of that actually work better for you, and you can just track the performance of the models. And then finally, what we will do is we will actually create an endpoint to our model so we can access it. So without further ado, let's get started. But just to mention one thing here, because to run the cluster, it actually takes some time, and we don't have we don't have that much time actually for that. So what I would like to say here is that, in order for you to actually run your notebook on the Databricks, you need to actually create a cluster, and that's actually under the compute. So once you come here, so it will allow you to actually create a cluster. So once you create this cluster, you will just give all your for instance, demo cluster, and that's it. So once you click on create, so it will take some time, but then it will create the cluster, because if you do not have a cluster, you will not be able to actually run this notebook. And the final step is, if you come here on the top left side, so here you will have to attach that cluster to this notebook file, and that's it. That's all that you need to do, and all the computation that you will do will happen actually on a cluster. So we will just get started. So as I said, we'll be working on the wine quality data set. So there are, I'll not spend much of the time on the machine learning part of it, because I think it's more important to spend more time on the production and how actually the ML flow works in the Databricks platform, itself. So we have this data set, and what we do is we'll perform some data preparation, data pre-processing, and then we will do some visualization of the data. And then we will create another column that's the quality of the data. All the wines that has a score greater than 7 will be qualified as a high quality wine. And after that, we will pre-process our data. So we look for any missing values. And then once we have that, we will just perform the train test split to actually do the model training and then for the model validation. So now this is the key thing that I think you all should pay close attention to, is we are using ML flow here. And the reason why we're using ML flow here is basically to keep a track of the parameters that we are using, to keep a track of the metrics the model is giving us, and to see how the model is performing, and we can actually keep it in one particular place. So in the context of ML flow, that's a registry. So you guys can think of it as a database. So you create your model and you put it into a database. So you can after some time, you can just go and retrieve it and see how the model works. But here, that's a little different. So it's nothing is different. You just instantiate your model, you fit your model. But what ML flow does is that it logs the parameters. So for instance, the number of estimators used to train the model, and then what was the the precision of the recall, or for instance, area under the curve score and stuff like that. So it actually logs your metrics. And then for ML flow, and now this is actually again an important thing to note here, is for ML flow to deploy your model from development to production, it initially has to keep that model into its registry. So how would it be able to keep that model? ML flow cannot directly take that model. For instance, we created this model here and we just pass it to this. Rather, what we will do is we will just create this small wrapper class, and then what we'll do is, once we have this model, we will pass it here, and then we'll use this mlflow.log model to actually log this model. And now we will have this model in our ML flow platform. So after all of this is done, we can just go through the feature and the important features, and we can see how much variance is actually explained by each of the parameters. And after that, we register the model here. So now our model is ready, and the ML flow actually has that the parameters, logs, and the model itself. So we can just say that mlflow.register model, and it actually takes a model and it actually registers that into the ML flow. So once we have that, now the model was in development. But in order for us to put the model and actually to create an endpoint to it, for instance, an API or REST API to call the model, we have to convert it into production. So once we have this, I think the name of the model is wine quality. So what we do is once we create the model, so that will be under this models tab. So if you come here, yeah, here is this wine quality data. So it has various staging. So currently, according to the notebook that we have, it is in the development phase. So what we will do is we will have to convert it into production so that we can finally call it like from anywhere, anywhere we can access that model. So we will write this one function. So what we will do is we will transition the model version from development to production. So once we have it, then what we will do is we will be able to load the model from the production rather than from staging, from the development phase, because the development is the same thing that we do. We just develop the model and we call it. But here we are loading the model from production, and this is basically one of the tests to see whether the model is actually performing well in the production or not. So finally, once we have our model in the production, we will do the model serving, and what that actually means. So the same model that we had here. So once we click on this model, here is this one on the top left side, it's serving. So when you click here, it allows you, okay, I have actually created that. So I will stop it to do it in front of you guys again. So this model, I'll go to serving and I'll say enable real-time model serving behind a REST API. So once I click on this enable serving, it will allow me, and it will actually give me this one URL, which I can use anywhere to invoke this endpoint. So I'll use this URL. I'll create my payload, and I'll just pass it the data. So for instance, I had created this one function to actually call this endpoint to that deployed model. And then here, what we are doing is we are just passing the X test. So normally how we pass X test to actually see how the model is working. So we have our the predictions, and then the actual results, like what the model predicts and what actually the results were. So the evaluation results and what the served model actually gave us. So we can actually see if they differ, if they are same. So that was pretty much about the demo. So today we just saw how we can actually do the development on Databricks from model development to production. So you just created the entire model in one notebook file and you put that into production. It gave you an endpoint, and anyway, anyone in the world, depending on the access that you have given to it, can just access it anywhere, and they just pass their payload and they can predict, for instance, here the wine quality. So yep, that was pretty much about it. And the final thing is and the last thing about the Databricks is after the demo is the pros and cons. So it has some advantages, it has some disadvantages. So it's basically a highly secure and reliable production environment. I believe one of the pros that I can add here, it is highly suitable when we have big data, and when we are when we have, for instance, very confidential data, and when we are extremely concerned about the data management. So this is when we can specifically use it the most, specifically for the data engineering teams in collaboration to data scientists, and then it allows us for powerful cluster management. It has secure data integration, instant access to latest Spark features, because as I told you, we will have to run actually and create a cluster for us to run the entire notebook, and it accelerates the ETL process and automatic recovery of clusters from failures. Some of the cons are it's not geared towards the end user. So for instance, it's just as we created this production. So this is mainly for the data engineers and data scientists. It doesn't do well on new products, depending on how much data they possess and if they have the need for some specific model and stuff like that. And costs can quickly add up. You must have, one thing that you guys should note here, if anyone wants to work on the Databricks, you must have an account on either AWS or GCP. In order for you to work on Databricks, I had created one account on AWS, and then I linked it with the Databricks, and then I was able to actually create that one notebook. Otherwise, I would not have been able to. So you must have a cloud account to create account on Databricks. And then integration of data could be better. It has lack of documentation and it does not have that resilient deployment strategy as I would say the one that my friend Eric will be explaining on the AWS SageMaker. So yep, that was pretty much about the Databricks. Thank you.
Thank you, Asim. So let's allow Eric to share his screen and talk about SageMaker.
So yes, so now we'll talk about SageMaker, another solution that also provide managed services regarding the machine learning data science lifecycle itself.
Sorry to interrupt, Eric. Can you put it on half screen as usual? Because I think you're on the big. Yeah,
I put it in full screen. That's fine.
Okay.
Never mind. So let's talk a little bit about SageMaker. So as I said, it's a fully managed solution for machine learning, and it contains several features that cover many aspects of the model lifecycle. And the target audiences are three role types, personas: the business analyst through the use of low code or no code services like Canvas, data scientists, mostly through studio notebooks based on Jupyter Lab, and also other services that help the data scientists organize trials and experimentation, and then ML engineers and MLOps engineers with the use of tools that even extends the two other type of roles through features that enable pipelines, model registry, project organizations, projects organization that help you organize pipeline, model endpoint, and monitoring. It's not an exhaustive list, but it's part of the main features that are targeting this third audience. So of course, we'll be looking at the tool through the third lens mostly. Also, SageMaker is also the SDK that allows to programmatically interact with the different features. As we'll see later in the demo, there are several ways to interact with each of these features. So you can do it either directly through point-and-click console or through a notebook that is running on the studio, and even in the most advanced cases, and what we've done already with some of our clients, set up Python projects that rely on the SageMaker SDK and other Python library to code pipelines and have them automated in a way that that is really abstracted, so they can apply that same framework or approach to many of their data science and machine learning model development lifecycle. Also note that there are many integration with other pipeline orchestration tools like Airflow and Kubeflow to delegate steps of their DAGs and their pipeline to SageMaker features. The main one being either trials or experimentations, as well as delegating the training part to SageMaker. These are two of the most notable examples. So let's talk a little bit about the features. This slide and the next one will talk about the available features through two different perspectives. In the case here, it's on Amazon SageMaker website. Here, the different features are divided according to the steps that you encounter in almost any machine learning project. So you have four main stages, even though I put one more, which are prepare, build, train and tune, deploy and manage. And as you can see under each part, you can see that different features that can be used directly through the console, notebooks, or a Python project help you help you address each part of the project. And sometimes in some cases, like for example in prepare, some features can be used together. For example, you can have your SageMaker feature store that contains your engineered features that you can query as if it's a classic SQL database with an SQL-like query through Athena inside the SageMaker processing job in order to build to prepare your data sets for training, testing, etc. And then with that, you can, once you've built that data set, you can move on to the building step, where you can use the different features. The one that is the closest to, for example, AutoML is Autopilot, which is the same thing, just renamed the same. Or in some cases, you want to specifically target some algorithm, but don't want to get the hassle of having to set up the library and whatever. SageMaker also provides built-in algorithm, and you can always have the option of bringing your own. And in some cases, like if you go the Python project way, you always have the option to use local mode to always prototype on your local machine and check if things work accordingly to the way you want before pushing your code and triggering the CI/CD pipeline that will run the entire pipeline on SageMaker. Then you will have the train and tune. Again, you have access to different features that are always here to support you with the different aspects. So you can have distributed training. You can also find a way to organize experiments to check which hyperparameter set is the most relevant, and then once you find that best hyperparameter, let's say, you can add hyperparameter organization, and these integrates really well with the built-in algorithm provided by SageMaker. But you can always go bring your own and have fun with that. Last, you also have an entire approach to deployment that you can do. Again, the three ways I just I keep describing all the time. And what is helpful with this is you can almost have your entire continuous model delivery pipeline, but inside that entire pipeline you can have two loops: one for preparing, building, and training the model, and then you register the model, and then the model registry is kind of the articulation with the second loop, which is more related to the deployment and model governance. So the main features related to that are SageMaker endpoints. And with these SageMaker endpoints, you also have the opportunity to use other services like CloudFormation in order to have a more of infra as code approach to deploying the model. And you can set up many things through this as with the rollout strategies. Like they are always developing that side, but for example, with the client, we are helping them set up a rollout strategy as well as deployment strategy for their endpoint. So when you have one version that is already running and deployed in an environment, we can deploy the second version and then gradually transfer the traffic to the next version in a smooth way. As you recognize, it's canary, so you can have that option, and there are other options, and you can go really far into that rabbit hole. And also, in addition to that, you have you have features that help you with model monitoring. It's pretty basic, but it's really helpful as well. And you have the option to either deploy directly with SageMaker, and they also have a feature for edge devices. So this is how things articulate around the SageMaker. Now we get the second perspective. It's still the same services, but from the feature store perspective. So the feature store is the place where you will store your your engineered features, and this can be used as a source of truth for either one or many models. And then what it helps you is have is to avoid repeating the same data processing, and also you can have a unified approach to everything related to features. And this feature store can be used as a source of data points for all the model development that is downstream, and we explained in the slide previously. As you can see, you can have several approach, either more of a batch approach or a streaming approach. So you always have that flexibility that allows you to again be able to develop models that answer many business problems in either batch or quasi real-time cases. So now let's move on to the demo. Let me open the right window. Okay. So as you can see here, I'm in AWS, and here we can have, we have the SageMaker interface on the left side of the screen. In that bar here, you can see that we have Studio, which is a Jupyter Lab. Also, they provide an RStudio version, but most of the time we work with Python. And finally, Canvas, which is the no-code, low-code option for business analysts. And as you can see here, you can have access to the many running jobs that are related to processing, training, etc., etc. So once I click here on Studio, I already opened the Studio itself because it takes a little bit of time to load. So as you can see here on the Studio, you have access to many things, and also things are organized in a certain way. So the first time it's a bit overwhelming, but you get used to it. So one of the most interesting features is that that Studio itself can be is associated to a domain. So on the operations way, you can have an organization per team. So you can have a domain for business analysts, or a domain for data scientists, and a third one that is really geared towards MLOps. And in many cases, you can also have features with a feature that allows you to clone stuff from Git. So in the case that you have a specific domain that run Studio instances that are related to experimentation, POCs and stuff, this can come in handy. And also it helps collaboration in the way that you can make sure that the work is done on a standardized, unified environment, so you don't get bad surprises. Now let's move to the more MLOps features. As you can see, on the left bar, I clicked on the last one, which is SageMaker resources, and here you can see the list of the different features that are really geared toward MLOps itself. So here we don't have a project, but one of the ways to approach that is to have a project per machine learning model inside the team. Today I already downloaded an example to show you how things run in SageMaker. So in that case, I cloned a notebook from a repo called AWS SageMaker Examples. It's full of gems when it comes to identifying the best practices with the SageMaker pipelines and other features. As you can see, there are many parts, and it addresses everything from feature engineering, model training, model evaluation, and things like that. As you can see, it's a long list, but one of the good sides with SageMaker, in the case you go in pipelines or through projects as well, you can look at the pipelines, at the pipeline history run, so you can always do some backtracking if something goes wrong. So as you can see here, this is a really visual approach to every step of the pipeline. And when you click here, you can always have information about inputs, outputs, and logs. And most of the time, the logs are stored in CloudWatch, and that's great again for everything related to debugging. So this is kind of how it works when it comes to the loop itself, to the training loop itself. As you can see, we start with processing the data and it ends with registering the model. So if I go in the model registry right there, you can see that the models are organized in a group package way, and every version, and you can see every version itself. So what's good, what's nice with this feature of model registry is that when you register the model, you don't only register one artifact, but you also register other things that helps with identifying the model performance. So you can have model quality, where you output metrics related to performance according to the use case. So in that case, it's a regression. So we have mean squared error here, but in other cases, it can be accuracy in classification, accuracy, F1 score, AUC scores, etc. Can also add through the different scripts and feature available through the SDK to explainability, bias report, etc., etc. And according to the model performance, you can always set up an option to approve the model according to metrics thresholds or manually. And in some cases, if you look at the blog, and it's something that we've implemented with clients, once the model is approved right there, it can trigger the second loop, which is the deployment loop. And what it creates is an endpoint. In this case, we didn't create an endpoint as it consumes quite some resources to deploy. But there are mainly two ways to deploy through code. So I mean through codes, through artifacts that are code-like, either through Python code or IAC. Once you go a little bit below, you can see that oh, I'm lost in the lines. You can see that somewhere in there. Somewhere in there, you can deploy a point through the code, and this create an endpoint that you can interact with. Note that these endpoints can, according to the way you configure them before deploying them, they can handle near real time or batch approaches. They can accept either JSON payloads or CSV payloads. And in the case you want to deploy something really custom, you always have the option of creating your own container to handle the specific types of requests, and there is a documentation that is related to that side of things. I think I'm done with my demo, so we can move on to the part where I discuss about the pros and cons. So SageMaker is a quite comprehensive tool, but you need to be aware of a few little drawbacks. But once you have that in mind, it's a really useful tool to empowering your analytics and MLOps team to deploy endpoints that can bring value to the business. So so SageMaker is nice because it offers a diversity of features that cover many aspects of the model lifecycle. Another thing is it can help you get projects up and running quite fast. It's high availability, extremely scalable, and flexible up to a point. The underlying infrastructure can be deployed using IAC as well, mostly through CloudFormation. It can integrate with compliance tools and framework, especially when it comes to things like ISO 27001 and other things like that. And also it integrates with other pipeline orchestration tools like Kubeflow or Airflow to run some steps on SageMaker and other steps that are outside. The little drawbacks of that tool are a steep learning curve when you get into more advanced and complex ways of using this product. It is fully managed, so you need to expect a higher cost due to many managed services layer. There is also the vendor lock-in issue. And the three last point are a lack of community. You don't see you don't see that many people online talking a lot about SageMaker, especially on forums like Stack Overflow. But you can still find YouTube influencers like Julien Simon. Trade-offs were made to favor speed instead of flexibility, again, to such an extent, especially when you want to have something, some parts of your operations that is custom made. And some parts of the product aren't well documented, or the documentation isn't really clear when it comes to implementing really specific things. So yeah, now I'll give back the floor to Mohammed to do the wrap up.
Yes, thank you, Eric. So that was great demos. And we've seen that both platforms have very good pros and but as well have some cons from their end. The design of both platforms is basically different. They've been designed differently. Why? Because Databricks was more designed really for data scientists and probably by data scientists. So it has a focus that usually data scientists would tend to like Databricks for that, because it's more suitable with the way they usually work and the kind of tool they use. SageMaker was more designed for ops people and more people like machine learning engineers or MLOps engineers. And it was probably designed more by software engineers themselves. So the way both platforms are completely different. And I would say that your preference would depend on your style. And basically, if you're a data scientist and a machine learning engineer or an MLOps engineer, you might like one another. Now, in terms of properties, here we collect a couple of them, including big data analytics, where we can see that SageMaker provide more in-depth on the analytics side. The experimentation tracking and model deployment, Databricks has an edge, mainly because they own and they've developed MLflow, which make it at the next level in terms of capability of tracking experimentation, especially that you're probably familiar with MLflow, and MLflow is a pretty complete tool in general for experimentation tracking, model versioning, model registry, and so. You can write in both like code in a familiar notebook environment. SageMaker integrated the notebooks within like an IDE similar to VS Code, and Databricks is more like pure notebook based in a certain way for the development on the platform. Both run on scalable infrastructure. I had a question earlier about the scalability. Both have that auto scaling capabilities. You can customize the different instances you work on, add up potentially GPUs or so, depending on what you want to do. SageMaker is more a general purpose development platform in terms of machine learning model, and Databricks, like I said, would tend to be more pure data science and data scientist focus. Databricks has that strong thing where it runs and you can use like Apache Spark and as well MLflow for managing your machine learning pipeline, and as well the big data development, which is different from the big data analytics, where you can use technology like PySpark and Scala. Another advantage or property that Databricks would have is regarding the data. Before being an end-to-end machine learning platform, Databricks is a data warehouse / data lake. So at the end, that's as well a very good strength they have, because usually when you tend to migrate your data to Databricks, you would tend to use Databricks as an end-to-end machine learning platform as well. In terms of deployment, all the team agreed that SageMaker has a better module for that than maybe Databricks, just for the deployment aspect. But yeah, those are the different feedback about both platforms and their property. Again, in terms of ability to say which one is better, I would say that they are basically different. They've been designed differently. They speak maybe to a slightly different audience at the end of the day. And both of them have pros and cons depending on the use cases that you have, the team that is working on the platform, and so. Stephen?
Yes.
It's Eric who is controlling the screen, and I have control over your screen. Yeah, good.
Okay, yes. So thanks for coming out for the webinar. I just included the link to the MLOps Institute's LinkedIn page, where we put out the daily content with like the top 3 tools, depending on what your position is and stuff like that. We actually had somebody reach out during the webinar named Andre, who decided that he would like to even write a blog post on a specific tool for the MLOps Institute that'll be extra content, which is awesome. You'll also be able to find the YouTube channel on this LinkedIn page, and also on the Slack channel that you can find by navigating through the website. And so we hope that we can continue the discussion going. In MLOps, if you guys have any questions, feel free to ask them in that Slack channel, as Mohammed does have access to it, so does Eric, so does Asim, so they can be there to answer any further questions that you have. And so we'd like to really get a powerhouse of knowledge for MLOps going with this.
Maybe before I move into the Q&A, I'll take the chance to talk about the Mlx Engineer Certification. Let me share my screen. So, perfect. All right. So we've developed like an MLOps Engineer Certification. The purpose of this is basically, we know that there is traction in the market today, and MLOps Engineer is a rising job, and basically a lot of people and even data scientists, they just want as well gain knowledge in the ops field for ML to basically gain autonomy and have more end-to-end overview of what's going on from an end-to-end perspective. This certification is basically a 12-week program. powered, of course, by Rocket Science and MLOps Institute. The program benefit is basically you'll have access during the 12 weeks to mentors to answer your technical questions and guide your career choice. If you want to move to MLOps Engineer Certification, you'll have access freely to industry expert webinars and conferences. We're building partnership with some of the MLOps conferences across North America, so you'll be able to have discounts and free access for some of them. You'll have, of course, access to all our material and interactive platform to practice your skills. Because if you don't practice in this field, basically the knowledge is not much useful. And of course, access to exclusive later job placement. So the opportunity potentially to help you get a job, because that's our goal. Our goal is to help to coach you and show you the field and help you gain knowledge, but as well support you to get a job as an MLOps engineer. The outcome of the learning will be basically you'll learn how to manage ML machine learning infrastructure on multi-cloud and on-premise environment. You learn how to containerize ML application, how to optimize and refactor machine learning code. So you'll become a beast into code refactoring, and understand, of course, data scientist challenges. You'll deploy basically CI/CD pipeline for machine learning workflow, very important piece. Orchestrate machine learning pipeline using Kubeflow, data engineering pipeline using Airflow, deploy ML model in REST API using Flask and Fast API, prototype end-to-end ML application with a modern stack. And of course, the work will be a collaborative work between the learners. So you'll have the chance to solve problem and build small teams to solve those problems. There are some requirements, of course, because this is like a niche intermediate plus level as a certification. So you will have to have a certain experience in software development, very small one. A data scientist is considered as having experience in software development, of course, experience and knowledge in Python, because that's the main language that we will cover. And if you're from a background of DevOps engineer, data scientist, data engineer, data analyst, software engineer, or any other IT engineer, will be more suitable. Of course, it's open as well for people not in those fields. We have an application process potentially. And the first cohort will be on the 15th of October 2022. So it will be in about like 2 months or so. The date isn't like finalized, but it will be around that date potentially. So Stephen will take the chance to send you, I will take the time to send you all these materials. We have we opened up like a pre-sale, like a pre-opening for the certification. So you'll have the chance to apply, fill in the form, and potentially be among the first. And of course, there is a discount for the people that register before the 15th of July. So that's it from my end. And as he said, everything will be sent to you by Stephen and our team. Now what I will do, I'll take questions. So let me see in the chat.
Just to add on that point, I will be posting everything in the MLOps Institute Slack channel. If you're signed up, if you consented to being in our emailing list, then yes, I can send it to you. But if not, then you can find it in Slack.
Yeah. Someone asked how this training is different from the Fourth Brain MLOps program backed by Andrew Ng. Well, this one is backed by Eric Hamel. So now, more seriously, I would say that that program is good. We've looked at it. But the only difference, the core difference, is the price. The Fourth Brain MLOps program is around $6,000 US. This program is around $3,000 US. So technically, we want to make it more affordable than maybe what Fourth Brain has to offer today. Any other question before we end up the call? you can ask your question on the chat. Of course, go ahead, Ali Reza. Or I could actually unmute you. I think it would be easier. Yeah, there you go.
Hello, can you hear me?
Yes.
Thank you. I have a question, and it's about the deployment of models. So the examples that you mentioned, both of them were somewhat like a prediction. But let's say we want to have like a chatbot, which requires the state of the prediction to be persistent. Is it like SageMaker or Databricks has the possibility to do that?
What was the initial part of the question? I'm sorry, I've lost it for a second. Go ahead.
Sorry. So my question is that let's say we want to have a chatbot which requires the state to do the next prediction. Is it possible to deploy such a model in Databricks or?
Yes, because at the end of the day, a chatbot is just an NLP engine. So you could use Databricks and SageMaker to deploy the different NLP engines used by your chatbot. But of course, you'll probably have to deploy yourself maybe an orchestrator that will orchestrate the different like sub components, which are other microservices that compose your chatbot. Because usually chatbots are not just one model slash microservice. They are basically multiple potentially microservices that would compose your chatbot. But technically, you could use SageMaker and Databricks for deploying those components of your chatbot.
My question is about like, because both of them, as I understand, they use like a REST API. So you wouldn't have the state of the client stored anywhere. So let's say not particularly in a chat, but just generally, if you want something to have the state of the client, is it possible? Can we do it?
What do you mean by the state of the client?
So like chat is a good example because we need to have the previous state, and we're not going to send everything every time.
Okay, I see. So yeah, it should be doable because at the end in your payload you can submit almost anything, so it shouldn't be much a problem.
That's my question. I don't want to send everything every time. I just want to like the endpoint to be to know the state, let's say.
For that, I think that's because I understand what you want to do. So you don't want to submit each time the state to your model. In that situation, I would tend that you deploy a custom. You can use SageMaker or Databricks for orchestration and development, but maybe for deployment, you might want to deploy your model in a more custom fashion, because just because you have some setup that has to be done inside your Python script, the deployment script that will be used by the microservice. That will allow to keep in memory the state of every previous prediction for every user session. Because if a new user start to chat, you'll have basically, you will need like a new potential user session with a new state submitted for that specific conversation.
Yes, okay, I understand. Thank you very much.
Yeah. All right. If no additional question, I think we can end the call. It was a pleasure, guys, having you with us. I wish you a good end of the year, the good end of the week, and let's potentially reconnect in the Slack channel, because we'll have probably another webinar planned in the next 6 weeks. And we'll uncover the subject of it very soon. Thank you as well, Eric. Thank you, Asim, and thank you, Stephen, for your time.
Thank you, everybody, and have a great rest of your week.
Thank you, everyone.